Okay, check out these two functions, one of which is written in an ordered pair form and one of which is written in a rule form. And we're going to deal with these and work with these in order to find some inverse functions and inverse function values. So first of all, let's find f inverse of 5. So I colored this one in red here as the input because if you look up at f, I color coded it with the inputs being green and the outputs being red. So green goes in, red comes out. Green is start, red is stop. So when we deal with the inverse function goes backwards along a certain function, as long as the function was injective to begin with, or one-to-one. So when we put 5 into the inverse function, that's equivalent to looking at the original function and finding out which input yielded 5 as an output, 5 in red. So we do not look at this point. This point would say that f of 5 gets sent to -2. But we want the one for the inverse, which means we want to figure out which input was sent to the output of 5 in the original function. So we're actually looking at this point over on the far end. It shows that the number 9 in green was sent to the number 5 in red. So the inverse of f is going to take the red 5 and send it right back to the green 9. So the answer to the first problem is 9. Now the second problem is g inverse of x as a rule. So g of x is 3x minus 5 over 2, and we need to find a rule for g inverse of x, which should go backwards through that function. So if g of x equals 3x minus 5 over 2, this is equivalent to saying y, the output, is equal to 3x minus 5 over 2. If we wish to switch the input and the output, that would be equivalent to saying something like x equals 3y minus 5 over 2, because generally speaking x is input, y is output. Now to solve this equation, let's multiply both sides by 2. 2x equals 3y minus 5. Then add 5 to both sides by the addition property of equality. And then finally divide both sides by 3. So y on this side and 2x plus 5 over 3 on this side. So it looks like we're finding an equation of 2x plus 5 over 3 equals y. And so this would be the inverse of g. 2x plus 5 over 3. 2x plus 5 over 3. So transferring back to the original, we would have g inverse of x equals 2x plus 5 over 3. And that would be the correct answer to this problem. Okay, now finally for the last application we have g inverse of g of 3. Now interestingly, since g is a function that goes from some domain to some codomain or some range, g inverse is going to just reverse that order. So actually the answer to this is just going to be 3. And no matter what number was right here, that same number would show up here, because the g and the g inverse undo each other. They're kind of like they're functions that undo what the other one does. But just for verification purposes, it might be kind of neat to notice that over here, let me do this in another color like red, that g inverse of g evaluated at 3 would be g inverse of g of 3, which would be g inverse of g of 3 would mean I'd have to place 3 into this function right here, and g of 3 would be 3 times 3 minus 5 over 2, or 3 times 3 is 9, 9 minus 5 over 2, 9 minus 5 is 4, so this would be g inverse of 2. And now if we place the 2 as an input into this function, then you can see that you would get g inverse of 2 being 2 times 2 plus 5 over 3. 2 times 2 is 4, so 4 plus 5 over 3, 9 over 3, which is just 3. but no shock, because we knew, if you understand what the inverse function means, that g inverse of g would already be 3 just because it undoes what the original function set out to do.